Now we will consider linear differential equation of first order. What is linear differential equation of first order? See, the differential equation of the form P dy by dx pxy equal to qx. Linear differential equation of this format is called linear differential equation of first order. We call it linear differential equation of first order. Here P and Q are either constant or function of x alone. They are either constant or function of x alone. In this case, the integrating factor is taken as p dx, or you can say px dx. Means if I multiply to this, I'll get the this differential equation can be integrated. Like if I multiply it with, say I write it as p dx, this integrating factor when multiplied throughout the equation will give you, will integrate, it will make this differential equation integrable, will make the differential equation integrable. So this can be written as d by dx of y px dx, and that is qx e to the power px dx. So if I write this as y e to the power px dx equals to qx dx, so I can integrate it. C is the arbitrary constant, so this becomes, or integration of qx px dx plus constant. C is arbitrary constant. So this is the final solution, right? So remember this one, right? Don't have to remember all these steps, this won't come in your exam. So remember the last line, y into integrating factor equals to qx into integrating factor dx plus c, where c is the arbitrary constant, right? Now we will use this and solve the differential equation. See how can, let's use this differential and solve the differential equation. Suppose we are given the question, see this differential equation. First of all, you reduce it to this format. You reduce it to the standard form, right? Py equal to q. So if I reduce it to this form, it becomes dy by dx plus I have to divide it by x cos x. The whole equation has to be divided by x cos x. So it will become tan x plus 1 by x and x cos x. So this is going to be a p, it's going to be a q, right? So the integrating factor is going to be, see this differential equation of first order is very, very important. Dx, or this is log sec x log x, or this is x sec x. So the solution is going to be y into integrating factor, the x sec x, and q into integrating factor, that is x sec x dx plus constant. X will cancel out, so this will be sec square x dx plus constant, or this is tan x plus c, where c is the arbitrary constant. C is the arbitrary constant. So this is going to be the answer. Y sec y xy sec x equals to tan x plus c. Let's go for the next question. Question is, consider this question. Again, you have to write it in a standard form, that is dy by dx plus py equal to q. So this is 2x 1 minus x square, and this is x upon 1 minus x square, right? So integrating factor in this case is going to be 2x 1 minus x square dx, right? So this will come as integration minus log 1 minus x square. But if I take 1 minus x square as t, then minus 2x dx is dt. Now this is 1 by 1 minus x square, right? So that will be y into if 1 minus x square equals to q into if 1 minus x square 1 minus x square plus dx plus c. So if I take 1 minus x square as t square, I can put minus x dx as t dt. So this can be integrated to minus t dt, and this is t square tq plus constant, or 1 by t square dt plus constant. This is 1 by t plus constant. So it becomes 1 by y upon 1 minus x square, and t is 1 minus x square plus c, or y can be written as 1 minus x square c 1 minus x square. The solution, right? Let's move to next question. First of all, write it in a standard form, that is dy by dx 3 upon sine x y, and this will be cot x. So the integrating factor is going to be e raised to the power 3 sine x dx, or e 3 cosec x dx. So integral of cosec x dx is going to be log tan x by 2, or this is tan cube x by 2, tan cube x by 2. So so the solution will be given by y into integrating factor tan cube x by 3 x by 2 and cos x tan cube x by 2 dx plus constant. C is the arbitrary constant. So here it will be cot x. This is cot x, right? So this can be integrated as 1 by tan x tan cube x by 2 plus c, and you know tan 2 theta as 2 tan theta 1 square 1 minus tan square theta. So we'll use this. So it is 1 minus tan square x by 2 tan cube x by 2 and 2 tan x by 2 dx plus constant, or this is 1 minus tan square x by 2 1 upon 2 tan square x by 2 plus constant. Now let tan x by 2 as t, right? So this is 1 by 2 sec square x by 2 will be dt, right? So this will be this can be written as dx also. So this can be written as dx equals to 2 dt 1 plus t square. So this becomes 1 minus t square 2 dt. This is t square plus 1, alright, plus constant. So 2 will cancel out. So this is t square minus t4 t square plus 1 dt plus constant, or this is, so if I multiply this t square plus 1 and this is t4, what I can do is this is minus t4 plus t square, so you divide it, it comes out to be minus t square, that is t4, and t4 minus t square, so this will be plus 2t square, that is 2, so this becomes 2t square plus 2 and minus sign, so this is minus 2. So I can write this as, this can be written as 2 minus t square minus 2 upon t plus t square plus 1 dt plus constant. So this can be written as 2t minus t cube by 3 and tan inverse t plus constant, right? So this is 2 tan x by 2 minus tan cube x by 2, x by 2 1 by 3, and 2 tan inverse t means it is 2 into x by 2, right, plus constant. And what was the LHS? LHS was y into tan q x by 2. So I write y into, and this is y into tan q x by 2. So this is going to be the solution. 2 will cancel out. This is going to be the solution of the differential equation. So now let's move to next question. See this question. Integrate 1 plus x square dy by dx plus 2xy minus 4x square equal to 0. We have to obtain the curve satisfying this equation and passing through the origin. So we have to evaluate the arbitrary constant over here. First of all, write it in standard form. So that can be written as dy plus dx 2x by 1 plus x square 4x square 1 plus x square. So your integrating factor is, so this comes as log 1 plus x square, that is 1 plus x square. So integrating factor is 1 plus x square, and this comes as q into if. So this is tx plus constant, or 4x cube upon 3, right? So this is a differential equation. This is the differential equation. Now we have to evaluate the constant. It is passing through the origin. Since it passes through the origin, so y equal to 0, x will also be 0. So it gives you c equal to 0, or the equation of curve is going to be 3y. That's going to be the equation of curve. The curve passes through origin,